Hi everyone, let's continue talking about the physiology of sleep. So I've already told you it's a reversible state of unconsciousness from which a person can be aroused if you give them any sensory stimulus. That's how you distinguish them from a coma, because coma is also a state of unconsciousness, but a person cannot be awakened from coma easily. And importance of sleep, it's really important because it helps to manage your cognitive and physical performance. Other than that, it boosts the productivity and overall health. And if a person doesn't sleep, uh, so he for long periods of time, so he or she can experience rebound sleep, that is uncontrollable urge to sleep. And also in rats, the experiment was conducted where it was um, found that 2 to 3 weeks of sleep loss can be fatal for rats. Then I told you that there are two types of sleep, REM and non-REM. REM is the paradoxical synchronized, desynchronized, sorry. So paradoxical, that means this is uh, the brain activity is similar to wakefulness, and there's high brain activity, there's increased metabolism, there's increased heart rate, respiratory rate, blood pressure, and basal metabolic rate, irregular and fluctuating. How about deep sleep? The brain activity is slow. There's slow brain sleep waves, slow brain waves, or delta waves, and a person, his heart rate and everything is steady and regulated. What about duration for REM? After every 90 minutes, there'll be a cycle of around 5 to 30 minutes. And deep sleep, if a person has been awake for long periods of time, so the first hour of sleep is normally deep sleep. Other than that, 75% of sleep consists of deep sleep. The dreams in REM sleep, they are remembered, whereas the dreams in non-REM sleep are not remembered. Memory consolidation happens in REM sleep, and cognitive benefits are more in the REM sleep. What happens in deep sleep? In deep sleep, restorative and tissue repair and growth. So restoration happens in the deep sleep, like tissue repair and growth and energy conservation. What about the EEG? EEG is desynchronized. It resembles wakefulness in REM sleep. In deep sleep, it has delta waves. Arousal is easier in the deep sleep because the brain has no stimulus, so it's easier to arouse. Whereas in REM sleep, it is harder to arouse. Rapid eye movement, obviously, in REM sleep, muscle tone is decreased in both of them. Then I told you about the waves that you have alpha, beta, theta, and delta. So electroencephalogram, it can reflect the levels of brain excitation. It can tell about the wakefulness, sleep, or the brain disorders like epilepsy. So alpha, beta, and delta and theta waves. So theta are normal in children. They appear during psychomotor, emotional states, disappointment, and frustration. What about delta waves? Delta waves are normally in deep sleep, in infancy, in surgical anesthesia, in serious organic brain diseases. Right? What about alpha waves when a person is meditating? Awake but eyes are closed. Beta when eyes are open and a person is uh, focusing on something, really trying to study. Other than that, you should know about the frequency, that frequency and voltage. Let's just talk about voltage. So voltage in beta waves is low, in alpha waves is high voltage, in delta waves is very high voltage. So you should know beta waves low voltage, alpha waves high, and delta is very high voltage. What about cycles? So cycles would be theta 4 to 7. Actually, lowest would be in delta, then theta, then beta, then there would be in alpha and then beta, sorry. So cycles, but that's not much of an important information, but it's okay, you can just read that the cycles are lowest in the delta waves, and then in theta, then in alpha, and then in beta. Okay, now where do these originate from? Very important. So T and theta, right? So this would have temporal. Other than that, this is occipital, parietal, and frontal alpha waves, and parietal and frontal beta. Theta would be parietal and temporal. What about delta? Delta, because it deals with what happens in delta. There's a lot of restorative effects, right, in deep sleep, so cortical region. And delta waves can occur strictly in cortex, independent of activities in lower regions of the brain. Now again, beta is the asynchronous one. Alpha is synchronous activity and it's low frequency. Alpha low frequency synchronous activity. Beta is high frequency. So beta you can see it's the highest frequency 14 to 80. So beta high frequency. And what about alpha? Low frequency. Alpha meditation, so synchronous activity. Beta asynchronous activity. and then you can see slow wave sleep and REM sleep, right? So just read this, give me a second, and you can read this meanwhile. Okay, so see over here, slow wave sleep has different stages. You can see that as well, and REM is similar to beta waves. Now let's go back and talk about sleep. Sleep. Wow, I feel so sleepy starting this. Just kidding. Okay, so sleep. Here you can see basic theories of sleep. There is an old theory and there is a new, relatively new and accepted theory. The old theory says that there's some excitatory areas of the upper brainstem. So in the upper brainstem, what is brainstem? Brainstem is midbrain, pons, and medulla. This is midbrain, pons, and medulla oblongata. So the upper brainstem, this consists of an region called reticular activating system. This is an activating system that ensures if the switch of reticular activating system is on, the person will be activated, he will be awake. So the old theory said that as the day goes by, a person's reticular activating system gets fatigued. Once this gets fatigued, it automatically turns off. This means that a person is no more active and he'll be sleepy. This is the old theory. What about new theory? New theory says that they're active inhibiting. They're active, like the brain actively secretes inhibitory factors. So those inhibitory factors are going to cause the inhibition of the wake centers, wakefulness centers, and they're going to cause a person to fall asleep. So, a center located below the mid-pontile level of the brainstem actively inhibits other parts of the brain, resulting the brain to fall asleep. So, the old theory was like it was based around the RS system getting fatigued. The new theory says that the brain actively inhibits some parts of the brain and causes the person to fall asleep. Now, there are also some neuronal centers, neurohumoral substances, and mechanisms that cause sleep. For that, neuronal and neurohumoral, when you talk about neurotransmitters, very important serotonin. Serotonin is basically a hormone that causes sleep. You need to remember that. What are the neuronal centers? Raphe nucleus. Raphe nucleus, if you can remember, this was also there when we studied the analgesia system. So this also helps to decrease the pain, so decreases pain. Then nucleus of tractus solitarius, rostral means at the backside hypothalamus, rostral hypothalamus, suprachiasmal area, and diffuse nucleus of thalamus. Let us be done with the so hypothalamus and thalamus. This is obviously diencephalon, right? What is diencephalon? Midbrain. Remember when we were studying, sorry, diencephalon is not midbrain, mesencephalon is midbrain. When we were studying prosencephalon, so I told you prosencephalon has telencephalon and diencephalon. So telencephalon is the cortex. What about diencephalon? All the inner things. So thalamus, hypothalamus, epithalamus, all of that. Subthalamus was diencephalon. So this is diencephalon. When you talk about diffuse nuclei of thalamus, they play a role in sensory input modulation. They suppress sensory input, causing sleep. So when a person has no sensory input, a person will easily sleep. So what is this? This is the diffuse nuclei of thalamus. They are going to do what? They're going to suppress any sort of sensory input and they're going to cause sleep. These are the diffuse nuclei of thalamus. What about the rostral hypothalamus suprachiasmal area? Suprachiasmal area is associated with the circadian rhythm regulation. Now, what does this do? The suprachiasmal area, it's going to release GABA. What does GABA do? GABA is basically an inhibitory neurotransmitter that is going to inhibit the wake promoting centers. That's how it is going to cause sleep. Right now, what are we studying? We're studying about all those things, all those factors physiologically that cause sleep. So first I told you about the diffuse nuclei of thalamus. Then I'm telling you about the rostral hypothalamus suprachiasmal area. The rostral hypothalamus suprachiasmal area, it is associated with the circadian rhythm regulation. What does it do? It releases GABA. This GABA inhibits the wake promoting centers. What about the diffuse nuclei of thalamus? The diffuse nucleus of thalamus, they basically suppress the sensory input. So if there's no sensory input, so basically if it's decreased, so the person will easily sleep because you do not want any sensory input to disturb you, you just want to sleep. Raphe nucleus, my favorite, very easy, it's in the pons and medulla area. Same with this medulla and pons area. Okay, this is one thing, this is one glitch that I hate the most in iPads. They need to fix this. I'm so sick of it. Anyway, so let me just open it and see. Yeah, right here. So we were saying that I was telling you about the sleep, right? Yeah, here. So come here. Yeah, medulla and pons. Raphe So raphe what happens? Its fibers project into the reticular formation, into the thalamus, hypothalamus, limbic system, and neocortex, and also the posterior horns of the spinal cord. What does it do? It's also very important in inhibiting the incoming sensory signals of pain. But another very important thing done by the raphe is it releases serotonin. Serotonin does what? It causes sleep. So it basically is a major site for sleep induction. Then nucleus of tractus solitarius processes visual sensory signals from vagus and glossopharyngeal nerves, contributes to sleep by inhibiting reticular activating system. Very important. This inhibits reticular activating system. Oh my god, I hate this glitch by Apple. They really need to work on this. If anyone knows how we can, or anyone has figured out how we can sort this out, please let me know. Okay, so easy. So over here, this secretes serotonin. This inhibits RAS. This does what? This releases GABA, and this is associated with the circadian rhythm. GABA inhibits the wake promoting centers. Diffuse nuclear thalamus, it suppresses any sensory stimulus. Now these are if there are lesions in sleep promoting centers. What are the sleep promoting centers? All of these. If there are lesion in these, a person would have intense wakefulness. So they're saying discrete lesions in the raphe nucleus or bilateral lesions in the medial rostral suprachiasmal area. Suprachiasmal area was secreting GABA. Raphe nucleus was secreting serotonin. Then you had what? You also had the diffuse nuclei in thalamus, and you also had the nucleus of tractus solitarius, which was doing what? Which was inhibiting the RAS system. So if there are lesions in this, there would be less inhibitory impulses to the excitatory reticular nuclei. So this was done by the nucleus of tractus solitarius. If there were lesions there, there would be less inhibitory signals to RAS, right? Because of which what would happen what will happen, there'll be intense wakefulness. Prolonged wakefulness will cause, if a person has been awake for long periods of time, so if you take a blood sample and you see, look for some sleep factors, you're going to notice muramyl peptide, delta sleep inducing peptide, and other potential sleep factors. But very important, muramyl peptide and delta sleep inducing peptide. And what are the possible causes of REM sleep? What causes REM sleep? Acetyl secreting neurons. Acetylcholine basically causes REM sleep. These are the sleep and wakefulness cycle, and these are the functions of sleep. These we'll cover in the next video.